Today we're going to use those key features of a graph from lesson 1, and we're going to apply it to graphing quadratic functions in standard form. So there's 3 forms we're going to learn about. Standard form is one of the 3 forms. It often involves sometimes the most amount of work in order to graph a function. This is a standard from Algebra 1-2. Some of you may or may not have been exposed to it, so we're going to go over it right now as if it's the first time you are seeing it. So the very first thing I need you to recognize is that in this problem, A is 1, B is 8, and C is 15. That's the first thing I would do. If you're learning how to graph in standard form, that's the very first thing I would do. Okay? Second thing we're going to do is we need to find out, if we're going to graph this, where does this parabola shape occur on the graph? So my second move is I'm going to use this formula. And this formula allows me to find the axis of symmetry. The axis of symmetry is sometimes referred to as a line of symmetry. Please make sure all earbuds are put away, all cell phones are put away as well. Thank you. So I'm literally going to come up above and I'm going to see what was my A and what was my B, and I'm going to plug it into this equation. X equals negative B over 2 times A. So I'm putting parentheses wherever I'm plugging in values. 8 is my B. A is 1. And then I'm doing the math. So negative 8 over 2, and that reduces to x equals negative 4. That is going to be 2 things. It's going to tell me where is the parabola going to occur, where is the vertex, and it's only one part of a vertex because a vertex is an ordered pair. And so I'm going to start by locating where is negative 4. And I know this isn't a pretty graph, and we'll have pretty graphs when we move on to future problems, but we're going to go over here to negative 4. 1, 2, 3, and 4. And you can use a pencil or pen. I'm going to use a highlighter so it stands out, and I'm going to make a dotted line. So I know 2 things right now. I know the equation of the axis of symmetry, also known as a line of symmetry, is x, because it cuts through the x-axis. X equals negative 4. That's one thing I know. The next thing I know is that the vertex is going to be somewhere along this. But I need to know what is the y value so I can place the vertex along this line. Pick up your graphing calculator, please. I'm going to go back to the original function, and wherever I see an x, I'm going to substitute in what I came up with, which was negative 4. So I'm going to do parentheses. And whenever I'm plugging something in, I have to use parentheses. So here we go. Negative 4 squared plus 8 times negative 4 plus 15. Looks good. I graph it, and I get an answer of negative 1. That's the output. It's the y value that is associated. It's the y value that is associated with the vertex. So again, this is my vertex, and the vertex is at negative 4, negative 1. Now, if you look on my board, which I know you can't see if you're watching this virtually, you see a list of numbers. Everybody look on the board. 1, 4, 9, 16, 25, 36. Those are all perfect squares. If you happen to have that table, please take it out. It's a table of perfect squares. Please take it out if you happen to have that table. I'll put a pile of these. You do need to keep these. And so if you are at home or rewatching this, we were looking at perfect squares. And why does that matter? Because when I think about the most basic quadratic function, we call it the parent function. This is the most basic quadratic function. It's the simplest form. So 0, 1, 2, 3. Now I could go 4, 5, right? It goes ongoing. But let's just do the first 4. Now when I substitute 0 in for x, 0 squared is 0. The output is 0. When I substitute in 1, 1 squared is 1. 2 squared is 4, and 3 squared is 9. I want you to recognize that pattern. 0, 0, 1, 1, 2, 4, 3, 9. That's going to provide us a shortcut to graphing quadratic functions. So the first thing I have to do is I have to analyze this. Can everybody come up here? And please draw an arrow in front of the x squared. When the number in front of the x squared is a 1, I am happy. Life is easy. The general shape of this parabola has not changed. And if you're wondering, like, what do you mean? How could parabolas change? This would be like a general shape. And how parabolas could change is they could become wider, or they could become, they could become much skinnier. And that's all determined by that number in front of the x squared. So when that number in front of the x squared is just a simple 1, positive 1, I don't have to change any of this. And here's how you can use this pattern as a shortcut. Please go to the x's and draw an arrow going left and right. Go to the y's and draw an arrow going up and down. These are simple directions. That's all they are. Next to 0, 0, put in parentheses vertex. Wherever we see that dot, that's our vertex. Wherever we see that dot, that's a vertex. We're going to think of that as the 0, 0. And the directions all go from the vertex. It's going to make more sense if we do this together. So although this is not the point 0, 0, it's negative 4, 1, we're thinking of it as 0, 0. We're thinking of it as 0, 0. So from 0, 0, I want to go right 1 and up 1. So from here, go right 1 and up 1. Now we're going to come back to the vertex. Go right 2 and up 4. We always start back at the vertex. Right 2 and up 4. 1, 2, 3, 4. And lastly, I'm going to go right 3 and up 9. Right 3. 1, 2, 3, and up 9. This is 1/2 of the parabola. Parabolas are symmetrical. Whatever you do on the right side, it's going to be exactly the same on the left side. So there's 2 ways you can cheat. I want to show you the 2 ways that you can cheat. If you want to do it one way, you're going to go left 1 and up 1, go left 2, up 4, go left 3, up 9. Some kids like to do that, so I want to demonstrate that right now. You go left 1, up 1, then left 2, up 4, left 3, up 9. That works. I kind of do it a different way. So the quickest way, I think, is I find where this next dot was, and I go, okay, that's 1 away from the midline. So I'm going to go 1 away in the opposite direction, and I make a dot. This is a distance of 2 away at this line. So I go 2 away, 1, 2, and I make a dot. Here, I know this isn't drawn exact, but this is 3 away. 1, 2, 3. So I go 3 the opposite direction. 1, 2, 3. And now I connect them. And we have our parabola. All right, so now we're going to go back to lesson 1, and we're going to analyze this parabola, and everything we do needs to be precise. So that goes down to writing things in the correct interval notation, identifying the exact intercepts, all of that. We want it to be precise. So we're going to come down below, and we're going to start with the x-intercept and the y-intercept. Now the y-intercept is wonderful. In standard form, please circle what's called the c-value. The c-value is always going to be the y-intercept in this form, so 0, 15. And I always suggest we look back to the graph and we're like, does that look about right? Well, if here goes up to 9, 15 would be about here, and that looks about right. It would cross over the y-axis at about 15 with our sketch. Now, x-intercepts, we have to be exact. So look at this. When we find a y-intercept, x is 0. Guess what? When we find the x-intercept, y is 0. So put a 0 right away into that position. Now let's go back to the original equation. We put 0 in for y. So I'm going to rewrite this, but put 0 in for y. So 0 goes in for y. Not all trinomials are factorable. When it is factorable, it makes life pretty easy. So let's start here. 1 times 15 is 15. I want to think of 2 numbers that multiply to give you 15 and combine to give you 8. That's going to be positive 3 and positive 5. So I'm going to start by writing this down. We have x squared plus 15. You're following along and doing the same thing on your paper with me. Okay, so I have plus 3x and plus 5x. All right, please move ahead, and I want you to factor, and then we'll solve together. I want you to factor, and we'll solve together. Okay, how do we do this, Miss Bradley? So I'm going to underline the first 2 terms. Got it. I can factor out an x. I'm left with x plus 3. Whatever's in parentheses, I'm going to write again. What times x is 5x? That's going to be a plus 5. So I have 5x, awesome, and I have 15, awesome. Okay, that's great. The front and the back contain the same quantity. They both contain x plus 3. In front of the first parenthesis is x. In front of the second parenthesis is 5. Make sure we're setting it equal to 0. What we're doing right now is we're using the concept of factoring, which we've already learned in past weeks, and we're applying it to how we can now identify the precise x-intercepts of a quadratic function. Take each one of these and set it equal to 0 and solve. X plus 3 equals 0, x plus 5 equals 0. Again, this is a freshman level concept. It's very possible you did not learn it or you did not master it based on working with the previous classes this week. So the exact answer is -3 and -5. Now I got to go make sure my graph shows that. So I come up above and I'm like -3, yep, that's an x-intercept, -5, yep, that works. We've got those two. Okay, next we're going to go on, and now the rest is going to be very little work. It's going to be analyzing using those key features. Please write increasing, I'm going to abbreviate because I'm lazy, and decreasing. So this function, if we look at it from left to right, there's 3 things you have to remember about increasing or decreasing. Can somebody remind us of one of those? What do we always use with increasing and decreasing? Parentheses, awesome. So everybody put parentheses on right away. Parentheses right away. Second thing is we have to look at the graph from left to right, and then when we look at it from left to right and we identify where is it increasing and where is it decreasing, we have to describe it using x values. So from left to right, I'm going downhill, so I'm just going to write decreasing. I'm going uphill, and as a quick reminder, bless you for anybody who maybe forgot, at this point down here called the vertex, turn to the person next to you whether you don't know them or not. Are you increasing or decreasing at that point? At this point, are you increasing or decreasing? Are you going up or are you going down? Who says increasing? Hands up. Awesome. Who says decreasing? Who says neither? The answer is neither. Think of yourself right now. You are riding a bicycle or you are running. You're going downhill, but when you get to this point, are you going up or down? You're resting. You're not going up or down. And then you start to go uphill. So as we described this is going down. So I find decreasing. In terms of x values, it's coming from the far left. I describe that as a negative infinity. And it will continue to decrease until it gets to an x value of -4. After it leaves this resting place of -4 and you move to the right, it increases. Again, this is the equation for axis of symmetry. It describes what I have on my paper as that orange line. Now let's do another one. We have 3 left to do. Let's write down domain and range. At this level of your math, all quadratic functions until we start to do piecewise functions, which means we take a linear and we combine it with a quadratic and we make a new type of function. At this point, bless you, your quadratic functions, there'll be no limit on how far it will go to the left, in this case as it goes up. There'll be no limit how far it goes to the right as it goes up. So with no limits, we say negative infinity to positive. That will be the case for domains always at this point in your math career. Now that will change if we're looking at a real world application problem. Range, we always start negatives first and goes positive seconds. How low does it go? It goes to as low as what value? Is it -4 or is it -1? How low does it go? -1. And there's a point there. I need to include it. There's no limit how high it goes, so it goes to positive infinity. And our very last type that we need to analyze here, I'm going to throw it a different color, is we need to do end behavior, which we learned in Unit 1. So this is what end behavior looks like. We are going to fill in these boxes that describe what's happening at the ends. Now the very nice thing about quadratic functions is that when you look to the far left and far right with quadratics, they're either both going up or they're both going down. So in this case, as I go to the far left and far right, the function in both cases is headed in which direction? It is headed up. I don't write the word up, I put a positive infinity. Example number 2. What looks a little bit different about this? There is something different. Anybody see what it is? I heard somebody just say it when they're talking to their partner. Yep, do me a favor. Draw an arrow here and put a little ugly sign. Like, oh no, because there's one more step here that we have to do now when we do this problem. We're going to start it just like we did the previous problem. Just like we did the previous problem. So here's my first step. I'm taking a separate piece of paper. You don't have to, just so I write large. A is -1, B is 2, and C is 8. Okay, so I did my A, my B, and my C. That's my first step. So a lot of times students say, like, where do I start? That's where I start. Then I start with negative B over 2A. So whenever I have to plug something in, I'm putting a parenthesis there. So my B is 2, I substitute in 2, my A is negative 1. If you're not confident in your division skills with integers, then use a calculator. I have negative 2 on top, I have negative 2 on the bottom, and they are going to simplify to 1. So I'm going to write x equals 1, and I'm going to circle it. We just did two things. We located where that line of symmetry, also called the axis of symmetry, is, and we located one of the two coordinates for the vertex. So what do I do with that? I come back over here. I'm going to use a highlighter. You don't have to. I'm going to find where x equals 1, and I'm going to graph it. So I did two things. Line of symmetry and axis of symmetry are the same thing. I just figured out what the x value for the vertex is. Now I have to figure out the y value. And figuring out the y value, you can grab a calculator. But I do want to tell you the way you plug this in matters, and that most students in my previous hours did not plug this in correctly. So I would like you to follow along with me. So I'm going to come up here, I'm going to substitute in an x value of 1, and I want to know what is the output, or the y. So first just write down a negative sign. That's separate from the x squared. Now put down your parenthesis, type in 1 squared. Notice my 1 is separate from the negative sign out front. Plus 2 times 1, if you don't have a calculator, please go grab one. Plus 8. Whatever I get for my output is going to be the y coordinate of the vertex. My answer is 9. Okay, you ready? So I write 9 here. I'm going to go up to my graph. On this line, I'm going to go up to 9, and I'm going to draw a dot. Daisha, do you mind if I call on you for a simple question? Are you comfortable? Okay, Daisha, do you remember how the A value impacts whether your parabola opens up or your parabola opens down? Do you remember that fact? That's okay. Does anybody else remember? Yes, go ahead.
If it's negative, it's in this direction, the opposite and
Let's all write this down at the top. Negative A. Whoa. Negative A value. Negative A value. I'm just going to draw a parabola opening down. Positive A value. We're going to draw a parabola opening up. Simple as that. So if you make a prediction, you're able to then to see when you make a mistake along the way. Yesterday I was teaching, and I made a prediction with the class. We looked at the graph, and I was like, I did something wrong, because what my prediction is did not match up with my graph, and then I had to go back and find the mistake. So let's make a prediction. Is this parabola shape opening down, or is it opening up on our A value? Okay, now, I like to do the least amount of work to get the answer right. And so, you ready? You're going to answer this for me out loud. You ready? Please do this off to the side. 0 goes with, 1 goes with, 2 goes with, and 3 goes with. Now, I want you to draw an arrow to the y. If there is an A value that's anything other than positive 1, we have to adjust the y. By adjusting the y, the shape, Eric, please stand up for me. Take notes while you're standing up. Can you get him a small board to hold on to as he takes notes? By adjusting let me go back here, I gotta think what I was saying. By adjusting our A value, so we're given a negative instead of a positive 1, we now have to adjust the shape. So what this does is whatever number is here, if it's anything other than 1, we have to do up here. We have to go times negative 1. And it always only impacts what the y's are. Okay, you ready? 0 times negative 1, well, that's still 0. 1 times negative 1, negative 1. 4 times negative 1, negative 4. 9 times negative 1, negative 9. All these is we created this from the parent function, and it allows us to give really simple instructions. So remember, this is our vertex. I'm there. I always do the right side of the parabola first. So from here, I'm going to go 1 to the right, and guess what this tells me to do? I'm going to go 1 to the right and 1 down. 1 to the right, 1 down. Go back to the vertex. 2 to the right, 4 down. 2 to the right and 4 down. 3 to the right and 9 down. 3 to the right and 9 down. Then please do the opposite side as well. And there's 2 different ways we talked about. You could go 1 left, 1 down, 2 left, 4 down, and so on. I choose just to go, this is 1 away, this is 2 away, this is 3 away, 1, 2, 3.
I think it's not correct.
You think I'm wrong?
Yeah.
Okay, I love it. Why do you think I'm wrong?
When you go down -9, you have to stay on the x-intercept.
Well, let's wait and see if we got it. Does that make sense? We're going to figure out our x-intercepts, and then we'll check to see. If our,
Put your point at 8 and not 9, that's
Yeah.
the issue.
Your
You put
vertex
your
is
first
in
point at the wrong
-9.
spot.
I put my point at the wrong spot. Didn't I go up 9?
No, you want to be 8.
Oh, so I counted wrong. My 5-year-old could have counted better. I got it. So this should have been right here. Is that correct?
Yeah.
Okay, look at that. Sorry, Antonio, I didn't understand you correctly. I was like, I don't understand him, so I'm just going to keep going, and then I'll find my mistake. I got you. So we're right here. What she's saying, if you're watching this video, is that I should have gone over 1 and up 9. I went over 1 and up 8. I counted wrong. That is correct, right, Katie? Thank you for explaining what he was saying. So I'm going to do the same thing. It's going to look like the same shape, but it's going to be in a different place, right? So I'm going over 1, down 1, over 2, down 2, or down 4, then over 3, down 9. Again, if you are not with us present and you're wondering why did I just do that, we determined the vertex was at 1, 9, but when I graphed it, I didn't graph 1, 9, I graphed 1, 8. And so we adjusted that accordingly. One of the standards says that you must show algebraically what the x-intercepts are. So I'm going to grab this, and I'm first going to identify the y-intercept. That's really easy. Please circle what the c value is, and then when I write that down, remember when we find the y-intercept, x is 0. And likewise, when we find the x-intercept, y is 0. So I'm already going to put a 0 in place there. So 0 goes in for the y. I come up to this original equation, I'm going to put in a 0. So 0 equals -1x squared plus 2x plus 8. Again, this standard says you have to show algebraically how to find the precise x-intercepts. So with this, here we go. 1 times -8. So a times c is -8. I want to know, are there 2 numbers that multiply to give you -8 and they combine to give you a +2? That means that the 2 numbers must be different signs. Got it? It also means the larger number or the big number of the 2 has to be positive since this b value is positive. So I'm going through the answers, and I believe that the digits would be 4 and 2. 4 must be the larger, so +4, -2. So I'm going to write this down. You should be doing the same. -1x squared, leave a blank, plus 8. Now in this position, it doesn't matter which one you do first, so plus 4x and minus 2x. It all goes back to what you learned. It all goes back to what you learned, okay? I'm going to underline here, and I'm going to choose to take out, I don't know, I think I'm going to take out that negative sign. You don't have to, but I think I'm going to. So -1x. And I'm left with x minus 4. Let's make sure I did this right. -x squared, +4x. Then I write down whatever I had, and I have to achieve these back 2 numbers. What times x is -2x? That would be a -2. Is -2 times -4 8? It is. So they both have an x minus 4, and then we have a -1x minus 2. You're going to set each one of these factors or parentheses equal to 0 and solve at this time. Oop. When you get done doing that, then I want you to look at the graph that I corrected, thanks to Katie and Antonio, And let's see, is our prediction of what we graphed right? Is 4 and -2. Now, if I'm a student, I'm like, hey, Miss Bradley, like, why do I really need to go ahead and show this work when I can see on the graph exactly what it is? That's what the standard says I have to grade you by. So yes, I have a -2, and I believe that if this, oh, that went over too many. I believe that if this graph was done just a little bit neater, we could see that it does cross at -2 and +4. Wait, we got those done. Now, I think that's hard work. We're going to do from this, we're going to do increase, decrease, domain, range, and behavior. So let's start with domain and range. Remember, all parabolas that you're looking at right now are negative infinity to positive. But let's understand that. Although this opens down, as it's going to the left, it keeps going down. There's no limit how far it goes to the left as it goes down. There's no limit how far it goes to the right as it goes down. No limit here. The negative one has to go first. The range, we always start with the negative first. There's no limit how low it goes, but it goes up as high as a value of 9, and there is a point at that value. And behaviors next. Okay, next up, we're going to fill these in. Whether I go to the far left or far right, in both cases, this function is headed down, negative infinity. Please write increase and decrease off to the side. So we have to only use parentheses. I've did that. And then the next is we have to read this from left to right. So from left to right, we are going up, we're resting, and then we're going down. So I'm going up, I'm resting, and I'm going down. If you're somebody who struggles with identifying increasing and decreasing, I have found that when students actually identify in the graph, and even at this resting point, they identify what is the x value. I found that that helps them. So this is the increasing part. It comes from the far left. And it continues to increase until it gets to 1, and then it gets to rest at the top of the hill. Now, after it leaves 1, it starts to go down, and so as it moves to the right, it will continue to go down or decrease. As it moves to the right, it will continue to go down or decrease. We have our third example, 2x squared minus 6x plus 3. Y equals this quantity. We know it's going to create the shape of a U. Please put an arrow above the 2 and make a little frowny face. It means I'm going to have to do a little bit more work. Turn to your partner. Does this mean that the shape of the parabola is going to open up or open down based on that value in front of the x squared? Anybody? What's it going to do? A value is 2. Opening up or opening down? It's opening up. It's like a smiley face, okay? So we've just already made one prediction. Here's the next thing. Let's write down our A, our B, and our C. So that's the first thing you should do. Write down your A, write down the B, and write down the C. The next thing is we're going to do x equals negative b over 2a. So I'm going to put a parenthesis wherever I'm plugging in a value. The negative sign stays out front, and now I'm going to plug in the b value and the a value. Okay, you ready? So negative 6 goes here, and 2 goes here. A negative 6 becomes a positive, and a 2 times 2 is a 4. This reduces, if I divide both by half, to 3 over 2. So in our minds, we could write 3 over 2 or write 1.5, please. 3 halves or 1.5, they are equivalent. Come back to our graph. We've just done two things. We've identified the line of symmetry, whether you write it as a fraction or decimal, and we've identified the x value for the vertex. So I'm going to go to 1.5 and be as accurate as possible here. 1.5. Now grabbing your graphing calculator, please. I'm going to go to the original function, and wherever I see an x, I'm going to put 1.5 in parentheses. Please do the same. When I press enter, I'll have an output value. That output value is the y. So I press enter. I want to go to negative 1.5. Negative 1.5. So find negative 1.5. So it's right here, and I go negative 1.5. Okay, let's make our little pattern over here. 0, 0, 1, 1, 2, 4, 3, 9. And then this has to be times 2. Whatever number is in front of the x squared, whenever it's anything other than a positive 1, we have to multiply it by the y's in order to create a shape that models this function. So I'm going to do that right now. 0 times 2 is 0. 1 times 2, 4 times 2, and 9 times 2. Okay, now I'm going to take my time here to do the best I can. Here we go. So this is our vertex. I'm going to go right 1 and up 2. So I'm in the middle here, right 1, up 2. Go back to the vertex, right 2, up 8. 1, 2, and now up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right 3, up 18. Well, I know that's going to be past this graph, so I'm okay with us just having these. Now I'm going to go back here. This is 1 away. There's 1 away. 1, 2, 1, 2. And we can see when that a value is greater than 1, it creates a skinnier looking parabola. Check with your partner to make sure they understood how we graphed based on adjusting this table. Talk to your partner. You don't have to be besties with them. Check in with them at this time, please. Okay. We have to always do x-intercepts algebraically. So I know the y-intercept, that's the easy part, is whatever number's in back. In this form, standard form, the c value is always your y-intercept. When I figure out the x-intercept, y is 0. So I'm going to come back here. 0 equals 2x squared minus 6x plus 3. So we may be able to solve using factoring, but when factoring is not possible, doesn't mean we can't solve this trinomial. It means we have to use the quadratic formula. Let's see if factoring is possible. 2 times 3 is positive 6. Can we come up with two numbers that are the same sign, they're both negative, and it allows me to multiply to get a positive 6 and combine to give you a negative 6. So some students would say like 1 and 6. Yes, they multiply, but they combine to give you a negative 7. So some students may say negative 2, negative 3. They multiply, but they combine to give you negative 5. That means this isn't factorable. It doesn't mean we can't do this problem. Please write down the quadratic formula. Now I'm going to leave a parenthesis wherever I'm going to plug in a value. Notice that division sign is going to go underneath the entire numerator. And now I'm going to plug in the correct values. So my b value is negative 6. And the a value is positive 2. And my c value is 3. And if you can do that, honestly, this problem's not that difficult. A double negative, a negative times a negative is a positive. So x equals 6 plus or minus. I'm going to leave this alone. I'm going to show you how we can use a calculator to do that portion in just a little bit. Put 4 on the bottom. We are not about rounding things here. We're about giving precise, simplified answers. So grab your calculator. Do not put down a square root. This is called the discriminant underneath, and we'll learn later how it allows us to make predictions on what the solutions are going to be. At this time, we're going to plug in only what's inside. So negative 6 squared, subtract 4 times 2 times 3. Negative 6 squared, okay. Subtract 4 times 2 times 3. And I get an answer of 12. Now, please take out that beautiful paper that we worked with last week. And I want to know, is 12 a perfect square? Is 12 on this list? Okay, take 12 and divide it by 9. Is it a nice answer? Take 12 and divide by 4. Is it a nice answer? Okay, so I'm going to rewrite this, and I'm going to put the 4 first. So 6 plus or minus 4 times 3 over 4. And now I know the square root of 4 is 2. Do we have to do all this work? Yes. that denominator is like, it's like your sibling who's your favorite sibling. The sibling who shares everything, who's kind. And so this 4 is always going to be shared with both the left and the right, every single time. But it's shared with the numbers that are like numbers, like the 6 and the 2 are like the 4, okay? So I'm going to write 6 over 4 plus or minus 2 over 4 square roots of 3. That's one way. I'm going to show you an alternate way because we could reduce this down to 3 over 2 plus or minus 1/2. This is totally fine, but I want to show you another way. Maybe you're like, I don't really want to separate them. Fine. So at this stage, you can recognize that what I'm underlining, these are the like terms. They are all divisible by 2 because they're all even. An alternative is 6 divided by 2 is 3. 2 divided by 2 is 1. 4 divided by 2 is 2. These are equivalent. These are equivalent answers. If we plug those into a calculator, which we're going to do together, we're going to be able to see, is the prediction that we made in our graph equivalent? So after this, I'd like you to grab your graphing calculator. And I think it's easier to plug in this one. The first time we do this, we're going to add. Grab that graphing calculator, please. Again, we're going to add. So type in 3 plus 1 square roots of 3. And I want you to press enter before you hit divided by 2. So you're going to do 3 plus 1 times the square root of 3. Enter divided by 2. So this tells me that I believe one x-intercept should be just a little past 2. Let's check and see if that's right. Is it a little bit past 2? It sure is. Okay, I'm feeling good about this. Now the next one is we're going to subtract. 3 subtract 1 square roots of 3. We're going to press enter again and then divide by 2. Okay, I believe the other one should be about 0.6, 0.63, 0.63. Yes, it looks like a little bit past half. Okay, I feel confident. These are the x-intercepts. Which one do you want? I want you to write down either one. They are equivalent. So again here, the x-intercept, I would write this down, and you could just simply write x equals 3 plus or minus 1 squared to 3 over 2. With your partner right now, I want you in 1 minute to identify in integral notation what is increasing and decreasing intervals. Go. Interval notation, go. Luis, will you check to make sure Miss Diaz is in the room real quick, or if I need to unlock the door? Thank you. If you're going to think, like, Miss Bradley, I'm really stuck right now on how do I do increasing, decreasing. The first thing I'm going to tell you to do is make a parenthesis for both. The next thing is we're going to analyze this always from left to right. So from left to right, I'm going down. So decreasing, I take a rest, and then I'm increasing. So in the decreasing, this comes from the far left. This comes from the far left. So it comes from negative infinity, and it decreases all the way down to, now I need to identify the x value, which is 1.5. It decreases from the left all the way to 1.5, and then it gets to rest. Now after it leaves 1.5, at x value 1.5, and it moves to the right, it is increasing. Turn to your partner. You have another 30 seconds. Please do the domain and the range. Domain and range. There is no limit how far it goes to the left and the right for domain. So it'll continue to go up as it moves to the left. It'll continue to go up as it moves to the right. Now the range, this goes as low as negative 1.5, and there's no limitation on how high it goes.